So we're now ready to talk about the implementation of the FuturesCollector class. And this implementation is something that you can get at this link. It's available a number of places because I do this a lot in my different example programs, but this one's in the EX8 project in the Java 8 folder in my GitHub repository. So let's talk about how to do this. So the FuturesCollector class implements all the methods defined in the collector interface. So it's basically implementing a custom collector. There's three parameters that are passed to a collector. The first is the type of input elements in the stream that we're processing, which in our case will be a stream of completable futures to elements of type T, which for us is a big integer, but this is a generic reusable FuturesCollector class, so we make it T instead of big integer. The next parameter is the type of the accumulator, which is used to define the mutable result container. And that, in this case, is a list of completable futures to type T. That's what it'll be used to store this internally. And the third and final parameter is the result type that's the output of the collector, which is what the so-called finisher method will end up producing. And in this case, we're going to get back a completable future to a list of elements of type T. So notice the transformation that's going to take place between a list of completable futures to type T and a completable future to a list of elements of type T. And I'll talk more about that. That's what the finisher method does. That's where all the cool complexity is being hidden from users. So let's start by talking about the factory methods that are involved. The first one is the supplier factory method. And this returns a supplier that the Java Streams collector framework uses to create a new mutable result container, which in this case is an array list container. And you can see we return an array list constructor reference, which when invoked, when the get method is called by the stream framework, it'll make a new array list. And that'll be used internally to be the mutable result container object. This is the type that the container will store. So it'll be a list of completable futures to T, or an array list of completable futures to T. The accumulator is a factory method, returns a by consumer, this guy, and that's used by the streams framework to add a new completable future into the mutable array list container, the mutable result container that's storing the elements in the stream. And you can see all this does is it returns the list add method, and list add is very simple. It's going to take a list, and it's going to take the item to add, and it adds the item to the list. Since we're implementing a non-concurrent collector here, and we're using it only in the context of sequential streams, we don't have to worry about having to put a lock on this add. This is only ever called in a single thread, so there's no need for locks whatsoever. The next method is called combiner, and this is a factory method that returns a binary operator that merges two partial array lists together into a single array list. This is only relevant for parallel streams. We're not using a parallel stream, so this method is not going to be used, but you still have to provide it anyway, just because that's what the streams framework expects. So what we do here, if we were to use parallel streams, we would end up merging results together, sub-results together, and we would take one list of completable futures and another list of completable futures, and we would add the other, or the another, to the one, and that would be returned as the result from this call. This method is only also ever called on a single thread, so we don't need to worry about locks. The next method, which is really the most important one for our discussion, is the finisher method. And this is a little bit obscure at first. A lot of times you don't need to use a finisher. If you end up having the contents of the mutable result container after all the elements in the stream have been accumulated, if that's the final result, you can make the finisher a no-op by saying you have identity finish, which means don't call the finisher. However, if you need to transform the elements in the mutable result container into some other return type, which is what we're doing here, then you need to implement the finisher. And that's exactly what we're going to do. So this factory method returns a function that the Java Streams collector framework uses to transform the array list mutable result container into the completable future result type, because we want a completable future to come back from this thing. So here's the way to look at this. What you can see here is we take in a list of completable futures to type T, which is this futures thingy here, and then we get back a completable future to a list of elements of type T that have been finished and completed. So let's take a look and see how this works. So the first thing to note is that the syntax here is very mystical, and I'm in my slide deck, not my IDE, but were I in my IDE, I would show you what's really going on here that would make more sense. If you were to expand this to be an anonymous inner class as opposed to a lambda expression, you would see that there was actually a method called apply, because that's what we're returning. We're returning an instance of a function. And it has an apply method, and the apply method is going to be passed in the futures array list. And that's what's stored internally by the streams framework. It's going to pass that in when it arranges to call the finisher. So this is the reference to the mutable result container, which is the array list in our case. What we do now, and this is very funky, and I wouldn't want to have to write this code myself, so it's much better to put it into a library and do it once. What we do is we take the list of completable futures and we convert it to an array of completable futures by using this wacky syntax that is useful because we need to get the type information here for this. So this is actually going to convert the list to an array of completable futures. This syntax is just completely weird, but you just have to suck it up and deal with it. And what we do is we then pass that array, which could have an arbitrary number of elements in it, so it's an arbitrary-arity call, on the allOf arbitrary-arity method, and that will then return a single completable future that completes when all the completable futures in the array that was passed as a parameter have completed. And then what happens is we use a completion stage method called thenApply, and after that completable future, that one and only completable future completes, the thenApply method will get called, and thenApply then goes ahead and runs an action that will convert the list of completable futures into a completable future to a list of completed futures. It's kind of a mouthful to say that. And here's how this works. The first thing we do is we take that futures list, which we got from the streams framework, and we turn it into a stream of completable futures. And those completable futures are all completed at this point. If they weren't completed, thenApply wouldn't get called. So all we need to do is we need to use the map method to convert the stream of completable futures to objects of type T into a stream of completed futures of type T. So this call to join is really just to convert those things into objects as opposed to completable futures, and that call will never block. We then collect that stream of objects of type T to a list of objects of type T, and then we return a completable future to that. That's what thenApply does. It returns a completable future to the list of completed completable futures. And that's what comes back here as the return value. Now, again, I think you'll appreciate the fact that this is tricky, subtle code. And so it's the perfect kind of thing you want to put into a library, write once, marvel at, and then use it in the context of the streams framework and never have to think about how it works again. A couple other methods here. We have the set method, which just says that this is going to be unordered. And the last method we have here is the only one that doesn't override something that's predefined in the collector interface. This is the collector factory method, which returns a new futures collector. And that's what gets called here in order to return a completable future that triggers when everything is done. And then when it's finished, we call thenAccept at the outer stream level, and that goes ahead and sorts and prints the results. Notice that this thenAccept call, of course, is different from that thenApply call. So thenApply is being used inside, that's internally here, and then out there we use thenAccept to print things when we're finished. Okay, so that was the walkthrough of the FuturesCollector class. Very, very cool. You'll see all kinds of variants of this class I use throughout the examples and the assignments. In fact, if you look at your assignment, assignment 3 uses a variant of this that has a stream, I believe, instead of a list, but same basic idea.